Alright, so now that we have our definition of a rock, we are going to start going over different rocks you may find in nature. We'll start with igneous rocks, then we'll go to sedimentary rocks, and then we'll finally end off with metamorphic rocks. Igneous rocks, in many ways, their formation is the simplest. They form by the freezing of magma, and this occurs anywhere between around 650 and 1100 degrees Celsius, depending on the composition of the magma. And magmas are not homogeneous in their composition. They vary quite a bit, so different parts of the magma may freeze out before other parts, and things may remelt and refreeze. It's a fairly complicated process, which we won't delve too much into here. But what this means is that igneous rocks vary compositionally quite a bit, even if they're from the same parent magma. Now, the other way they vary is texturally. Specifically, there are extrusive rocks that form at the Earth's surface. These have an aphanitic texture, which means you cannot see the crystals with your naked eye. This is opposed to intrusive rocks, which form by the freezing of magma deep within the Earth. And these have a phaneritic texture, which means you can see the crystals with your naked eye. And all the rocks at the bottom, these bottom three rocks rather, these are all phaneritic intrusive rocks. They formed at depth. Let me get this right, but I believe this is a granite, a diorite, and a gabbro. Though, as you can see, quite hard to tell these two apart, so you need to be in a lab and use different tools and ID the minerals to do that. And compositionally, we generally group these rocks into felsic and mafic rocks. So starting with texture, again, aphanitic texture, they cool quickly above the ground. Because they cool quickly, small crystals are formed, and you cannot see these with the naked eye. So for example, a basalt would be a good example of an extrusive rock, like the ones you see erupting in volcanoes on Hawaii. Phaneritic, intrusive, they cool slowly below the ground, and these plutons, these igneous formations below the ground, well below the ground, they form larger crystals that are visible to the naked eye. And how we know about these rocks is, these plutons may have formed millions of years ago, and then over time the rock above it is eroded away, and then the pluton eventually reaches the surface where we can see it. An example of an intrusive rock would be gabbro, which is the intrusive equivalent of basalt. This one here. Now, on the extreme end of phaneritic is pegmatitic, where we see rocks that cooled very slowly, but most importantly also cooled in the presence of some water, which allows for even larger crystals to grow. So even compared to phaneritic rocks, these pegmatitic rocks, have very large crystals. So now looking at composition, again we have mafic and felsic rocks, and these are distinguished in a couple of ways. Firstly, if you look at these formulas over here, the cations are different. So generally with your more mafic rocks, you see a lot more magnesium and iron present. You can get some other stuff like calcium too. But if you go down all the way to the bottom to our more felsic rocks, we generally see more potassium and sometimes more sodium as well, like with albite. And the other thing you see is the silicon-oxygen ratio. At the top with your mafic rocks, you see generally a 1:4 ratio, so less silica rich. At the bottom here, we see a 1:2 ratio, more silica rich. So when you're looking at a formula, you want to think if it's mafic or felsic. Look for iron and magnesium versus, say potassium, and also look for the silicon-oxygen ratio especially. So using texture and composition, we can group igneous rocks into different types that we've assigned names here. We'll just start through this chart. We'll start with euphonic, the surface rocks. Rhyolite is a very felsic rock, has a lot of silica in it. Then you go over to andesite, which is more intermediate. And then mafic, less silica, more iron, more magnesium. You get your basalt. Now, if you get the same compositions as above, but you form them deep underground, the intrusive equivalent of a rhyolite is a granite. A lot of silica there still. Intrusive andesite is a diorite, sort of moderate composition between felsic and mafic. And again, the intrusive form of a basalt is a gabbro. Now with phaneritic rocks, if you get material that's really, iron and magnesium rich and really depleted in silicon, what the composition of the Earth's mantle is, then you can get ultramafic rocks known as peridotites. And you can actually find these in different parts of the world, including in Oman and including in Newfoundland, in Gros Morne. Now, these days, geologically speaking, we don't really get the formation of extrusive ultramafic rocks. There are a few rare examples, but for the sake of this presentation, we'll just omit that. Now, in addition to aphanitic and phaneritic, there are a couple of other textures that you can get. Vesicular rocks form in very gaseous magmas where you have lots of dissolved gases that are undissolving from the magma and escaping. You may have heard of pumice, the rock that can float because of all the air bubbles in it. That's generally more felsic in composition. Scoria is sort of the more mafic version of pumice, and scoria, it still has these air pockets, but it can't really float. And you can also get these glassy rocks like obsidian, and obsidian forms when the magma cools so quickly that there is no time for minerals to form, so it just forms this sort of amorphous material, this glass-like material, which doesn't have a crystal structure. Now, I've given you a really simplified version of compositions, and I just want to point out that rocks are not grouped necessarily by the elements, but are more properly grouped by what minerals you find in them. We're not going to go over mineralogy in this workshop. It is an entire course in and of itself. It gets very complicated. But if you're curious, this is how the different igneous rocks are classified mineralogically. And if you're interested, I encourage you to read up about mineralogy on your own. So that is igneous rocks. In the next recording, we'll do a brief overview of volcanoes.